The objective today is to explain the weaknesses and security flaws of encryption. So here's some thought-provoking prompts for you. How much easier is it to crack a Ceasar cipher than a random substitution cipher? So for a Ceasar cipher, there are only 25 possible ways to shift the alphabet. So the worst case scenario you have is that you'll only need to try these 25 different possibilities. Now a random substitution cipher has many more possibilities. 26 factorial is 4.03 times 10 to the 26. So if you're not really great at math, let me go ahead and explain this to you. What you're doing is moving that decimal point right after the number 4 over to the right essentially 26 times. So that's a very large number, right? So needless to say, random substitution cipher has so many more possibilities. However, as we learned with frequency analysis, we can avoid having to try all of them blindly. To better understand this concept, remember our lesson on permutations. So your think, write, share here is, in your own words, how much easier is it to crack a Ceasar cipher than a random substitution cipher? And can you put a number on it? So speaking of cracking things, computational tools aid humans in the implementation of encryption, decryption, and cracking algorithms. In other words, using a computer changes the speed and complexity of the types of encryption we can do, but it also increases our ability to break or circumvent encryption. Think, write, share in your own words. What are the benefits and drawbacks of using computers for encryption? And here I want you to think back to our bike lock discussion. Remember, this is typically called incorrectly a combination lock. It should be a permutation lock. So with that as a launching off point for you, go ahead and tell me about the benefits and drawbacks. So any encryption cipher is an algorithm for transforming plain text into ciphertext. What about the other way around? Can you write an algorithm for cracking a Ceasar cipher? What about a random substitution cipher? An algorithm for cracking a Ceasar cipher is pretty easy. For each possible alphabetic shift, try telling the computer to replace each letter with whatever number you think the shift is. So for example, if A equals C, the function would take a character as input and the output would be predictable. And saying how we studied functions not long ago, your think, write, share on here is to tell me what you would name a function that would be doing this shift. An algorithm for cracking random substitution is so much more trickier. There might be a single great answer, but through thinking about it, you realize how tricky it is to codify human intelligence and intuition for doing something like frequency analysis into a process that a machine can follow. It probably requires some human intervention, which is an interesting point to make. I like to think of Eobartan when I think of a substitution cipher. Recall that in RFC 3271, the Internet is for everyone, Vint Cerf wrote the following: Internet is for everyone, but it won't be if its users cannot protect their privacy and the confidentiality of transactions conducted on the network. Let us dedicate ourselves to the proposition that cryptographic technology sufficient to protect privacy from unauthorized disclosure should be freely available, applicable, and exportable. So he even talks about cryptographic technology in his talk about the Internet being for everyone. And seeing how net neutrality is a big topic in the news currently, I'm excited to read your response on this think, write, share. Do you agree with Vint Cerf? Why or why not? And what did he mean when he said cryptographic technology? Now that you know what goes into that technology, maybe you can better explain what he is saying. And here's an interesting excerpt from that book, Blown to Bits, about the importance of cryptography, okay? Your life, liberty, and happiness after the digital explosion. September 13th, 2001, fires were still smoldering in the wreckage of the World Trade Center when Judd Gregg of New Hampshire rose to tell the Senate what had to happen. He recalled the warnings issued by the FBI years before the country had been attacked. The FBI's most serious problem was the encryption capability of the people who have an intention to hurt America. It used to be, the senator went on, that we had the ability to break most codes because of our sophistication. No more. The technology has outstripped the code breakers, he warned. Even civil libertarian cryptographer Phil Zimmermann, whose encryption software appeared on the Internet in 1991 for use by human rights workers worldwide, agreed that the terrorists were probably encoding their messages. I just assume, he said, somebody planning something so diabolical would want to hide their activities using encryption. So what was needed, Senator Gregg asserted, was the cooperation of the community that is building the software and building the equipment that creates the encoding technology. Cooperation that is enforced by legislation. The makers of encryption software would have to enable the government to bypass the locks and retrieve the decrypted messages. And what about the encryption programs written abroad, which could be shared around the world in the blink of an eye, as Zimmerman's had been? The U.S. should use the market of the United States as leverage in getting foreign manufacturers to follow U.S. requirements for backdoors that could be used by the U.S. government. If you watch the news, this happened a few years ago where they recovered a cell phone from a terrorist in San Bernardino, and the FBI asked Apple to give them access to a backdoor or create a way for them to get into the data of the phone and hopefully find more terrorists. Now, Apple at first did not agree, and if I remember correctly, the FBI hired some hacker to work with them and break it, and now there's some conspiracy theories about this whole situation. But the point is, there still must be some sort of balance where companies that create technology, encryption technology, and obviously this would not be a type of question that you can answer on a test. However, I'm curious to see where you're at, so think right here. Do you agree that companies should provide backdoors for the government? And if you want to read more on this issue, there's the free book, Blown to Bits book that you could go to chapter 5, that is. But my one last note on cryptography and history is that cryptography, aka code making, and cryptanalysis, that is code breaking, have been at the heart of many momentous events in human history. The intertwined stories of diplomacy, war, and coding technology are told beautifully in 2 books. I suggest The Code Breakers by David Kahn and The Code Book by Simon Singh. In terms of what I think about privacy, I think privacy is important whether you have something to hide or not. My example is always to go back to the civil rights movement in the United States history. We have a situation where Martin Luther King Jr., if his privacy was ignored and the government knew what he was planning or the types of things he was about to say in his speeches, they could have countered that and really made this entire civil rights movement so much less effective, which now in hindsight we all know was an important movement to happen. So think about things like that when you think if you are okay with people invading your privacy because you have nothing to hide. It's a tricky issue, one that I don't have a clear solution for, but since we're studying cryptography, I would be remiss if I didn't bring it up. So specifically, how does cryptography work? Well, there's this RSA algorithm, and RSA comes from the names of the people who created it. It's one of the first practical public key cryptosystems. So public key encryption is very fascinating. We'll go more in detail about that later. But for now, just know that it is widely used to secure data transmission. The encryption key is public, and it is different from the decryption key, which is kept secret, aka it's a private key. In the RSA algorithm, this asymmetry is based on the practical difficulty of the factorization of the product of 2 large prime numbers, and this is called the factoring problem. RSA is a relatively slow algorithm, and because of this, it is less commonly used to directly encrypt user data. So here's another balance we'll talk about often in this class, the balance between convenience and security. The RSA algorithm involves 4 steps: key generation, key distribution, encryption, and decryption. So as promised, we'll go over that in more detail later. For now, this is a great website to play around with. You can basically create a message and encrypt it using emojis. And if you're finishing up early today and you want an extension activity, try to find a way to explain to me why prime numbers are so important to cryptography. Okay, so before we answer that IB question or fill in the blank, here's what the code emoji website looks like. So I typed in hello and it gave me emojis. And since we talked about 2 different ciphers today, you should be able to tell me what type of cipher this is. So here's the IB fill in the blank. Today's lesson was all about being what? And then your DOL. This message was encrypted using a Ceasar cipher. Let's see how long it takes you to decode the message. So I want to give you more advice on how to approach this, but because I think it's a great skill for you to be resourceful, I'm going to go ahead and just leave it be, okay? So here's the message you need to decode. If you're actually in my class, I'll paste this to Canvas for your convenience. So number 1, tell me what the message says. Number 2, what could have the message have said that have very serious implications, and what more can be done to protect such a message? So asking for a little creativity here at the end of the second question in the DOL.